So to determine whether something's soluble or not, you're actually going to refer to the data table, but it is also useful to have a general idea of whether you're on the right track. So there are usually numerous lists of solubility rules. I've just condensed it down to 3. So all nitrates are soluble, and all mostly group 1 chloride sulfates and ammonium salts are soluble. We'll have a look at polyatomic ions in a second so you know what that actually means. Hydroxide sulfides, so that's just S, whereas sulfates SO4 2 minus, and phosphates are only slightly soluble usually. So you don't have to worry, all the polyatomic ions are here. So ammonium salts here, it's NH4+. We have your nitrates, hydroxides, sulfates was somewhere, sulfates, phosphates, and so everything you need is in this table, carbonates. And then you basically, so once you can recognize what chemicals you have, you then just go to the second bit of the data book and you look at the combination. So the cations are all over here. So they're the metal cations, and the anions, which is the non-metal. So the polyatomic ions are regarded as non-metals as well. They're made up of non-metals, and you have just pure halogen non-metal there. And you can combine the two. So aluminium bromide is S for soluble, and so the definition of that is there you can put more than 10 grams per litre, dissolve it into 10 grams per litre, whereas something that is I insoluble, such as famously barium salts, such as, okay, so we've got barium sulfate is insoluble, so you won't be able to get any more than 1 gram per litre. So there's that's useful to know what those definitions actually are, because this is a little bit imprecise if you really want to know exactly what the story is. You could go Google solubility product constants, where you can know exact numbers and exactly how many grams in a particular situation. So moving on from there, let's go to an actual problem. So if you have copper sulfate and barium nitrate, what are you going to get? Are you going to get a precipitation reaction or not? And write the ionic equation for that, which gives you a hint that there will be a precipitate in there. So copper sulfate, so hopefully you've remembered how to write ionic formulas. You go to the data table to find out what these nitrate sulfates are. That's 2 as well, so cross multiply, so that's just CuSO4, so cross multiply, lowest common denominator, don't write the ones. So you end up with copper sulfate, barium nitrate gives barium sulfate, so it's a double displacement, so you swap these things around. So you got barium sulfate and copper nitrate. So if you go to your solubility table now, you'll find that barium sulfate is the only one here that is insoluble. I'll just quickly have a look at the rest. Copper sulfate, barium nitrate. So barium nitrate is soluble, and copper sulfate is over here at the end, and that's soluble, so we must have barium copper nitrate as well, and so that's soluble. So they're all S's, so you have one insoluble, and so the most important thing for these is to write the S, and you're done. So write all the states in, it's already balanced, and just to finish it off, this one's actually asked for an ionic equation. And so you keep the barium and the sulfate. So keep this and keep this. Get rid of the copper nitrate because that is in aqueous solution. So there's just Cu2 plus and NO3 minuses floating around. And so you will be left with that brought down, and then just the barium and the sulfate ions floating around. And so there you have your ionic equation, and that one's already balanced as well.